Host, Mr. Zhang, why is everything in the universe in motion? For example, the sun, moon, earth, as well as particles like electrons, neutrons, and protons, why are they all moving? Mr. Zhang, this is a great question. The truth is, in the universe, there are only two fundamental things, objects and space. Everything we see, from celestial bodies to particles, is in motion. But what causes this movement? The core reason behind the movement of objects is the movement of space itself. This raises another question. Why does space move? Here's an explanation. In our perception of space, we can define it using three mutually perpendicular lines. This is what we refer to as a perpendicular state, which is a simple way that human brains describe space. In reality, space is three-dimensional, and this perpendicular state in three-dimensional space can also be described in terms of movement. In other words, the physical description of motion is essentially the same as the three-dimensional perpendicular state. They are two descriptions of the same phenomenon. Our brains can describe this either as a perpendicular state or as a state of motion. Therefore, to understand this better, one must delve deeper into the concept of motion. In the unified field theory I am presenting, physical motion is described based on our observations. But it's important to note that the concept of static states is also based on our descriptions. Without our descriptions, it is uncertain whether an object is moving or stationary. Motion requires the existence of objects, space, and observers. The concept of motion and stillness only has meaning when all three are present. So, if you ask whether something is moving or stationary without considering these factors, the answer is indeterminate. What we truly know is that objects exist in space and move within it. Newtonian mechanics provides a view that motion results from forces acting on objects. While this view is not incorrect, it is superficial. It doesn't get to the root of the matter. Einstein's theory, which focuses on the curvature of space, offers a more nuanced perspective, but it is still not entirely clear. The unified field theory at present suggests that the three-dimensional perpendicular state of space is equivalent to the state of motion described above. Any object in this three-dimensional perpendicular state will inevitably change its position. For instance, electrons don't just move in straight lines. Their movement often involves curved trajectories. These curved paths and their interactions create perpendicular states. If the movement was strictly linear, it wouldn't form perpendicular states. In three-dimensional space, movement involves both linear and curved components. Hence, space exhibits a cylindrical spiral motion. This cylindrical spiral motion and the three-dimensional perpendicular state are interrelated, with one influencing the other. Host, please like, subscribe, and share.